Hello everyone, this is Raksha from Sri Venkateshwara College of Engineering. Currently, I am studying in a 6th semester in the Department of Computer Science and Engineering. Today, we will learn about the problem how to solve the SIC problems. In this session, we will know about the formats, addressing modes, object program format, and how to solve the problems related to the SIC method. Firstly, we will know the format. The format 1, it consists of the only one opcode which is of 8 byte. Format 2, it consists of opcode and 2 register. Opcode is of 8 byte, register 1 is of 4 byte, register 2 is of 4 byte. In total, it is of 16 byte. Format 3, it consists of a opcode and 6 flags and then displacement. Opcode, it consists of 6 byte and 6 flags. Each 6 flags consist of 1 byte, and displacement, it consists of 12 byte. Format 4 is similar to the format 3, but in place of displacement there is address, and that address takes 20 bytes. To differentiate the format 3 and format 4, format 3 in format 3 the e value will be 0. In format 4 the e value will be 1, and format 4 can be recognized by if the plus sign is present, then it can be recognized as format 4. The addressing modes, there are two types of addressing mode, that is base and program counter. In a base, the B flag will be 1 and the P flag will be 0. The target address can be calculated by the base address plus displacement. In the same way, the program counter, the flag B will be 0 and P will be 1. Target address can be calculated by the program counter plus displacement relative. Object program format, here there are three content. One is header, text and end. In header, the column 1 should be the head tag, the column 2 to 7 should be the program name, and column 8 to 13 should be the starting address of the object name in the hexadecimal. 14 to 19 should be the length of the program in the byte. Text, the column 1 should be the T tag, column 2 to 7 it should be the starting address of the object code in this record. Column 8 to 9, the length of the object code in this record in byte. In column 10 to 69, the object code represented in hexa should be present. In the end tag, the column 1 should be the E, column 2 to 7 should be the address of the first executable instruction object program. And now here will come to know the problem, and here we will see the problem, how to solve the problem. This is the problem format, and this will be the object codes for this. We need to find the object code and the location and the object program format. Here we will find the object code and the location, how to find the location of the CTR. The starting address 4005D should be written in the location place. That will be the starting location for the clear. Here the X will be the format 1, so we need to add 1 byte to the location, then we will get the 4050F. And then length is of the format 3, so we need to add a 3 byte, then we will get the 4062. In the similar way, output is of 3 byte, format 3, we need to add 3 byte, so we get 4065. And then W loop is also of the format 3, then we add 3 byte to the 4065, then we get 4068. Buffer is also of the format 3, then if we add 3 byte, then we get 4006B. Output is also of the format 3, if we add output is of the format 1, if we add 1 byte, then we get 4006E. T is of the format 3, T is of the format format 1, if we add format t is of the format 2, if you add 2 byte we will get 4070. Then w loop is also of the format 3, if we add 3 byte we get 4073. r sub is also of the format 3, if we add 3 byte we get 4076. This x byte x05 is of the format 1, if we add 1 byte we get 4077. And to find the object code, as x is of the format 2, we have seen the format of the format 2. It consists of opcode r register 1 and register 2. For the clear, the binary value will be the b4. For this we need to write the hexadecimal value. For b, the hexadecimal value will be 10110, and for 4 the hexadecimal will be 400. This value should be written in the opcode value. Then the register x value will be 1, so the binary value of the register 1 will be 0011, as there is no another register, so it will be 0. For this we get b4 1. b4 will be the value, b410 will be the object code of the first one, clear. Then if we come to the length, this is of the format 2, so according to the format 2 format, opcode and 6 flags and address as here it is written. Since the object of the LDT is 74, we will write this in the form of binary code. 7 binary value is 01110, 4 value will be 100. We will write here, since the opcode of the format 2 will be just takes the 6 byte, so the starting 6 byte will be written in the opcode, and ni value will be 1, as there is no immediate and direct addressing mode. X value will be 0, as there is no x register present here, and b and p value we will find the later. E value is 0, as it is the format 3. To find the address and b and p value, we have the displacement value, the 4036. First, we will take the address of the next register location of the next this one, then minus with the LDT value. LDT value will be length value will be 4036. Then we get the value minus 2c. This can be returned in the form of fd4. The address will be fd4. Then if we come to the td value, the output, this is also of the format 3. Same way we fill this format box and we find the output. And here we will find the object code for the JEQ. This is also of the format 3. In the same way, JEQ value will be the 30. So 3 value is 0011 and 0 value will be 4 zeros. As opcode takes only 6 byte, the starting 6 byte value is taken here. N and I value will be 1, as there is no immediate and direct addressing mode. X value will be 0, as there is no X register, and the P and B value we will find later. E is 0, as it is a format 3. Address we will find out here. Address we will find here. Displacement value will be 4000. Firstly, we will take the value of the W loop. W loop value will be 4062, and the next value of the address will be 4068. So we get minus 6. The minus 6 value will be FFA, so the address will be FFA. As it comes in the range of the minus 4048 to 2047, then it will be the P flag will be 1, as B will be 0. In the same way, the WD and WD value will be find out. We will find. In this session, we will know about the formats, addressing modes, object program format, and how to solve the problems related to the SIC-XE method. Here, we will know how to write the object program code. As we have seen in the earlier slides, how to write the form or what is the format of the object program. In the same way, we write the program. Firstly, a tag we will write, and then the name of the tag, then the starting address, then the length of the address, then t tag, then the starting address we write, then followed by the object codes, and the end starting tag we write. Thank you.